Yeah. Option F. Then you. Option A and D. A and D. Okay. Rahul. First one. Yes.
Option D.
Option D.
Yes, miss.
Okay. So, what is the definition of an algebraic expression? An algebraic expression is a combination of constants and variables connected by some or all mathematical operations. That's all. A polynomial is an expression in which the variables involved must have non-negative integral powers. A polynomial is an algebraic expression in which the variables involved have non-negative integral powers. So if you have to identify polynomials, then you have to check the powers of the variables involved. And the powers everywhere must be whole numbers. Okay. But here, which of the following are algebraic expressions? So you just don't have to check anything. Constants, variable. See, the first one, x to the power 7. Algebraic expression. Second one, you see some constant. Okay, the 4 is a constant. You can see the variables x and y. Algebraic expression. Only if you have to identify polynomials, you'll have to check the powers of the variables involved. And the powers must be whole numbers everywhere. So to identify algebraic expressions, you don't have to take any effort actually. Algebraic expression, algebraic expression, algebraic expression. You don't have to take into account the powers of the variables involved. They can be anything. The powers of the variables involved can be anything. Can be a fraction, decimal, whatever. It can be negative. All that makes algebraic expression. No. D also is an algebraic expression. Yeah, correct. So that means options A, B, C, and D all have algebraic expressions. So then which is the correct option? Option F. Option F. All of A, B, C, and D. There's one option which says none. Yeah. So A, algebraic expression, B, algebraic expression, C, and D, algebraic expressions. Option E says none. Option G says only D. Option F says all of A, B, C, D. So which is the correct option now? All of A, B, C, and D. All of A, B, C, and D is the correct option. Next one. Which of the following are polynomials? Which of the following are polynomials? Option B and D, is it? C, B and C. Yeah, all if you simplify. So you can simplify the options in A and C. You can simplify the options in A and C. Simplify and tell me. So in A we have 3 into fifth root of 18. 3 into fifth root of 18 divided by fifth root of x cubed. Fifth root of x cubed. Not finish the first one. Take down the first question. Yeah, write it out in your book. Yes. Correct. That should be simplified further. Yeah, online children, please finish the first one. Write the question, write down all the options, and then select the or circle the correct option. Yeah. You tell me. No, you ping me. I'll check that and do the needful. Yeah. Yeah, quite. No. Focus should be here. We can talk later. Finish the first one. Perfect. Finish the first one, all of you. Online children, finish the first one. The correct option
Yes,
was,
ma'am.
yeah,
Yes,
so the first
ma'am.
one, the correct option was F.
Finished, ma'am.
Okay. We'll simplify this. So it'll be 3 into 18 to the power, what was it? X to the power 18. Sorry, I made a mistake in writing here. X to the power 18. X to the power 18. So it'll be 3 into x to the power 18 into 1 by 5 divided by x to the power 3 into 1 by 5. So this is 3 into x to the power 18 by 5 divided by x to the power 3 by 5. Now by the law of exponents, when bases are same and its division, we subtract the powers. So 3 into x to the power 18 by 5 minus 3 by 5, which is 3 to the power, 3 into x to the power 18 minus 3, 15 by 5. 15 by 5 is 3. 5 ones are 5 threes are. So 3x cubed. 3x cubed. So this expression simplifies to 3x cubed. This is nothing but 3x cubed. So you must not, comment on the face of the expression. Just by looking at the expression, you cannot say if it is a polynomial or not. If simplification is possible, you should simplify and then comment and then decide. So you were right. Very good. Sai Smriti. So 3x cubed. Take down the simplification also. Here's the question. Take down the question first. Write the question, write all the options. See, you should have taken the first question, circle the correct option. Then take the second question, write all the options. But here the options have to be simplified before we decide the correct option or options. So first write down the question with the options. We haven't still answered it. We haven't still answered the second one, right? Yeah. Taking the question? Yeah.
Yes, ma'am.
Yeah. See, I can work this again for you. If you did not follow when I worked it the first time, I'll do it again. See here. First, we'll convert the radical forms to exponential form. So it is 3 into, we have x to the power 18 here, x to the power 18. This fifth root symbol, okay, this is the radical form. This one converts to the power 1 by 5, to the power of 1 by 5. So remove this fifth root symbol and in the power multiply by 1 by 5 divided by x cubed. Write this as it is. And this fifth root is written as to the power 1 by 5. So into 1 by 5 here. So that is the first step. Converting the radical form to exponential form. That's the first step. Now this is 3 into x to the power 18 by 5 divided by x to the power 3 by 5. Okay. Now by the law of exponents, bases are same, x, bases are same and it's division. So we subtract the powers. So 3 into x to the power 18 by 5 minus 3 by 5. Now 18 minus 3 is 15, 15 by 5. So it is 3 into 3 into x to the power 15 by 5. So 15 by 5 is 5 ones are 5 threes are. So 3x cubed. So the given expression simplifies to 3x cubed. The second one, you don't have to, or it cannot be simplified further because see, this is the constant. See, we have to simplify if the variable, see here, the variable x is under the radical sign. So here, since the variable is caught with the radical sign, we need to simplify to understand the power of the variable. See, how do we decide if it's a polynomial? We need to check the power of the variable involved, right? Variable or variables involved, right? So here the variable x is caught under the radical sign. The variable x is caught under the radical sign. So we are not able to understand the power of the variable x, if it is a whole number or not a whole number. So we have to simplify. To decide if the expression is a polynomial, we need to understand the power of the variable or the variables involved. It should be whole numbers everywhere. Now, in the first option, it is fifth root of x to the power 18. So the variable is x, but you are not able to clearly understand the power of the variable x because it is under the radical sign. So we have to simplify. Bring it to the exponential form, simplify, and here you understand that x is raised to the power 3, which is a whole number, so it's a poly. So this one is a polynomial. It looks like it is not a polynomial, but it is a polynomial. Now in the second option, root 7, not variable. It's not x, y, z there. So you don't have to write that as 7 to the power 1 by 2. That's a constant, root 7. All right. So you don't have to simplify anything there. See, x is the variable and the power is 2, which is the whole number. So we are able to identify the power of the variable involved. What's the variable here in the second one? X. What's the power of x? 2. Whole number. Now see this root 3 by 5. Root 3 by 5 does not have a variable there. Root 3 by 5 is a constant, right? It's a constant. So we are not concerned. It can just be like that. You don't have to decide anything with the value of the constant. So our concern is about the variable and its power. The variable is x, its power is 2, which is a whole number. So this one is a polynomial. Yes or no? So when should you simplify? If you are not able to identify the power of the variable or the variables involved. If you're not able to make out the power of the variable or the variables involved, then you have to simplify. Otherwise, you don't have to. Here we can see the variable is x, its power is 2, whole number, so polynomial, finished. The rest are all constants. Root 7 is a constant, fixed value. Root 3 by 5 is a constant. It has a fixed value. We are not, we are not going to, we have nothing to do with the constants to decide if it's a polynomial or not. Clear? Yeah. Next, root of x to the power 6, y to the power 4, z to the power 10. Root of x to the power 6, y to the power 4, z to the power 10. Minus 4 by root 7. Minus 4 by root 7. Very good. So is it a polynomial or not? It is a polynomial. So how do you simplify this? X to the power 6, y to the power 4, z to the power 10, the whole power 1 by 2. Because when you remove the radical sign, square root of, you should raise the base to the power 1 by 2. When you remove this radical sign, square root, you must raise the base to the power 1 by 2. Correct? Minus 4 by root 7. Now this is x to the power 6 into 1 by 2, y to the power 4 into 1 by 2, z to the power 10 into 1 by 2. Minus 4 by root 7. So now 2 ones are 2 threes are 2 ones are 2 twos are 2 ones are 2 fives are. So this is x to the power 3, y to the power 2, z to the power 5 minus 4 by root 7. So how many variables involved? 3 variables. And what are their powers? X is raised to the power 3, whole number. Y is raised to the power 2, whole number. Z is raised to the power 5, whole number. Minus 4 by root 7, that's a constant. We have nothing to do with that to decide if it's a polynomial or not. So option C, the expression in option C is a polynomial. But when you look at it, it's like, no, it's not. It doesn't look like a polynomial. It is an algebraic expression, but not a polynomial. No, you have to simplify. Why should we simplify? Because the variables x, y, and z, they're caught up in the radical sign. And you don't know the exact powers of x, y, z. So you have to simplify. Please complete this.
Finished, Miss.
Very good. Done? Finished?
Yes, miss.
Yeah. Finish writing, Anika? Yeah. Option D. Okay, we have nothing else to simplify. So far what? A polynomial, B polynomial, C polynomial, right? Now let's see at the other options. All of ABC, none of ABC. Yeah, that's it. So which is the correct option? All of ABC. All of ABC. All of ABC is the correct option. All of ABC is the correct option. So when should you simplify? For algebra to identify if the expression is an algebraic expression, you don't have to simplify. Just looking at it, you can say, yes, it is an algebraic expression. Only for polynomials, and that too if the constants are real numbers like root 3 or root 4 by root 5 by 7. Don't worry about the constants. You must be able to identify the powers of the variables. If you're not able to identify the powers of the variables, then you should simplify. Like in option B, second one, option B, we had root 7 and root 3 by 5. We have nothing to do with them because the variable is x and its power is 2. So we are able to identify the power of the variable x. Here I'm talking about. So no simplification is needed here because the variable is x and its power is 2, whole number. So this one is a polynomial. Okay, so this is the correct option. Third one, which one is a binomial of degree 100? So two conditions must be satisfied. It should be a binomial and the degree should be 100. Two conditions. Which one is a binomial of degree 100? Option D. Okay. Rahul says D. Yeah, Saismati? A. Okay. See, even when you're right, if I say you're wrong, you stick to your answer if you're sure about it. Yeah.
Miss, option B, miss. Option B.
B. Nuved Wahid. Option B. Okay.
Ma'am,
Come again? Who's that?
A, ma'am. Right.
Gayatri.
A.
A.
Yes, ma'am.
Okay. Gayatri says A. Okay. Surya. Surya also says A.
Ma'am.
Yes.
Ma'am. Ma'am, I think it is E, ma'am.
Is that Anita?
No, ma'am. I'm Dhanishri.
Oh, Dhanishri. Okay. Yeah, Dhanishri. So come again with the option.
Ma'am. E, ma'am.
E. Okay. Dhanishri says E.
Ma'am, I say A.
Okay. A. All right.
Ma'am, I say E.
Lakshana says E.
Yes, ma'am.
Don't mind if I have shortened your names. Lakshana says E. B.
I say A.
Who said B? Who said B? What's your name? Krish.
Ma'am, I said A, ma'am.
A. Haridarshan A.
Ma'am, I say E.
E. Yarni. E. Your name? Sanjay. Yeah, Sanjay. Okay. So even I have to give my option, right? Okay. Hmm. Anika? Okay. So the first one is a binomial. Is it a binomial in the first place? Okay. Answer this question. Is the first one a binomial?
Yes, ma'am.
Is the first one in question number 3 is option A a binomial?
Yes, ma'am. Yes, ma'am.
Anyone with answer no? Because I'm saying no.
No. No, ma'am.
Yeah, who's that?
No, I'm Lakshana.
Lakshana. Why Lakshana? Why is it not a binomial?
Because a binomial is a polynomial which has two terms, and
Correct.
in this case, it is like x to the power minus 100, where the power is negative. Therefore, it's not a polynomial.
Correct.
Therefore, we
Very
can
good.
consider it as a binomial too.
Correct. You're right. Option A is an algebraic expression with two terms. It's not a polynomial. Option A is an algebraic expression with two terms. It's not a polynomial. Why? Because when you bring this x up to the numerator, it will be x to the power minus 100 plus 12. Yes or no? When you bring this x up to the numerator, you must always have the variable or the variables in the numerator and then see the power. You must get the variable or the variables to the numerator and then read the power. 1 by x to the power 100. So when you bring x to the power 100 to the numerator, it will be x to the power minus 100. The variable is x. Its power is minus 100. It's not a whole number. So it's not a polynomial. Option A is not a polynomial. What's a binomial? A polynomial with two non-zero terms. A polynomial with two non-zero terms is a binomial. So option A is not a polynomial at all. Then how can you say it's a binomial? Just because it has two terms. It's an algebraic expression with two terms. It's not a binomial. Correct. So Lakshna was right. Yeah, second one. Second. Is the second one an is it an sorry, is the second one a polynomial? Yeah, because the variables are x and y and their powers are whole numbers. So polynomial, correct. But is it a binomial? No, it's not a binomial. So this is not a polynomial at all. So this cannot be the correct option. This one, because it's a polynomial but not a binomial. What about this? Is it a polynomial? This one?
It's a trinomial, ma'am, but it's not a binomial.
Yeah. Yeah, this one is a polynomial because the powers of the variables x, y, and z are whole numbers. The powers of the variables x, y, and z are whole numbers. So option C is a polynomial. X is raised to the power 25, y is raised to the power 50, and z is raised to the power 25. So x, y, z powers are whole numbers. It is a polynomial, but it's not a binomial, it's a trinomial. And also, the degree is not 100. It's a trinomial and the degree is also not 100. Okay. What about D? So A, B, C, no. A, no. B, no. C, no. What about D? We'll have to simplify, right? So it'll be x to the power 50, y to the power 48, z, yeah, z to the power 14 minus 7, right? Should subtract the powers. Z to the power 14 divided by z to the power 7. Minus 12, correct. So option D simplifies to x to the power 50, y to the power 48, z to the power 7. Why 7? Because 14 minus 7 is 7. Subtract the powers. So this, no, I've simplified. Division, no, subtract the powers. 14 minus 7. So it will be z to the power 7. So here it's a binomial, but the degree is 50 plus 48, 98, 98 plus 7. 105 is the degree. What if I made this, what if I made this 12? What if I made this 12? What is 14 minus 12? 2. Then 14 minus 12 is 2. Then is it a binomial of degree 100? Yeah. If this were 12, if this were 12, see here. If supposing this was 12, then it will be x to the power 50, y to the power 48, z to the power 14 minus 12. We are applying the law of exponents. When bases are same and its division, subtract the powers. 14 minus 12, 2. Minus 12. Now this is a binomial. This is the binomial. And what's the degree? 50 plus 48, 98, 98 plus 200. If it was 12, then it qualifies, it satisfies these conditions. But now, no. So option A, option B, C, D, none of them satisfy the conditions given in the question. So the correct option is none of A, B, C, D. And Danya said E. Danyashri said E. Lakshana also said E. Yeah, Sanjay and Yarni. Sanjay, correct? Sanjay, Yarni, Lakshana, and Danya. Very good. I'm sure all the others understood now, right? Got it now, all
Yes,
of you?
ma'am.
Now tell me, is the first one a polynomial? Why?
No, because it's not a whole number. The power is not a whole number.
Power is not a whole number. Because when you take the variable up to the numerator, it will be x to the power minus 100. So the power is not a whole number. So the first one is not a polynomial at all. Then you cannot say it's a binomial because it has two terms. Because for it to be a binomial, it should first be a polynomial. So what can you say about the first one? It's an algebraic expression with two terms, but not a binomial because it's not a polynomial. The second one is a polynomial of degree 100, but it's not a binomial. It's a monomial. The second one, option B, is a polynomial because x is raised to the power 50 whole number, y is also raised to the power 50 whole number. So it's a polynomial. And what's a degree? 50 plus 50. 100 is a degree. Degree is 100. But it's not a binomial. Two terms. It's not a binomial. So it does not satisfy this condition in the question. Then this one, it's a trinomial. And also, what's a degree? What's a degree here? What's the degree? In option C, what's the degree of the polynomial? Rahul, what's the degree? Option C.
Miss, in X we see that the degree is 25. The Y is 50 and Z is 25.
They are the powers, not the degrees. So the power of x is 25, the power of y is 50, the power of z is 25. So what's the degree?
What was
Okay.
Yeah, darling, what's the degree? You're reading out the polynomial. Why? No, I'm not clear with my question. I'm asking you, option C is a polynomial. What is its degree is the question. 50. 50, 50. You should not add the powers. If one term has many variables, then you should add the powers. These are different terms. You must not add the powers of, the different terms here. If one term, now this is the first term. In the first term, if you have more than one variable, this is the first term. Here in the first term, if you have more than one variable, then you should find the sum of the powers. This is the second term. Again, here, if you have more than one variable, you should find the sum of the powers. Likewise in the third term. But you should not add the powers of the different terms. That is the powers of the variables of the different terms here. Clear? See, if it was x to the power 25, y to the power 50, z to the power 25, and minus 7, then this is one term. Should find the sum of the powers. 25 plus 50, 75. 75 plus 25, 100. Here you should not add. Okay. So the second one, option C is a trinomial of degree 50 because the highest power is 50. Fourth one, D we understood. So the correct option for this question is none of A, B, C, D. Correct? Yeah. Complete this. So which one we have to work here? Only option D, right? Only option D we had to work for x to the power 50, y to the power 48, z to the power 14 divided by z to the power 7 minus 12. So this one simplifies to x to the power 50, y to the power 48, z to the power 14 minus 7 minus 12. So x to the power 50, y to the power 48, z to the power 7 minus 12. So the sum of the powers 50 plus 48 plus 7 is equal to 105. So degree is 105, but it's a binomial. Make a note of this working. Yeah, next one.
Just a second, ma'am.
Okay.
Done, ma'am.
Yeah. Yeah, the factors of a square minus 1 minus 2x minus x square are. Yeah. Take down the answer. This is of 8th standard. Try to understand and then I'll explain. Finished? See, all of you are expected to write the question with the options and then work the solution. Right? Finished?
Finished, ma'am.
Okay. Okay. So when you look at this expression, you can see x square here, 2x and 1. for like initially don't consider the signs. Just look at the terms. X squared, 2x and 1. Now we know that x squared plus 2x plus 1 is a perfect square. Why? X squared plus 2x plus 1. I said don't consider the signs first. Just look at the terms. X squared, 2x and 1. Now this can be written as x the whole square. This can be written as 1 the whole square. So like a squared plus b squared plus 2ab, 2 into x into 1. These three terms, x squared, 2x and 1, make a perfect square. X squared, supposing it's x squared plus 2x plus 1. X squared is x the whole square. 1 is 1 the whole square. So like a square and b square. Then what's the middle term? 2ab, 2 into x into 1. 2ab is 2 into x into 1. So see here, x the whole square is x squared. 1 the whole square is 1. And 2 into x into 1 is 2x. So this is of the form a squared plus 2ab plus b squared, which is nothing but a plus b the whole square, right? So these three terms should be grouped because they make a perfect square. So rearrange the terms. Write a squared first, then rearrange the terms. Write the x squared term first, so minus x squared. Then write the minus 2x term, minus 2x, and then minus 1. So first step is to rearrange the terms in the order x squared, 2x, and 1. This is the given expression. This is the given expression. All right. Write this a squared term as it is. Now then write the x squared term first. So minus x squared. And then this 2x term, minus 2x. And then this constant minus 1. Now take out minus common because the signs, like they don't suit the identity. It's minus x squared, minus 2x, minus 1. So take out minus common. Write a square as it is. Take out a minus common. So open bracket. Minus into x square is minus x squared. Minus into plus is minus 2x. And minus into plus is minus 1. Taking minus common. Minus into x square is minus x squared. Minus into plus minus 2x. And minus into plus minus and 1. Now, I'd given you one more step here. No? So now these three terms are of the form a the whole square plus b the whole square plus 2 into a into b, which makes a plus b the whole square. X plus 1 the whole square. So we have a square minus x plus 1 the whole square. A plus b the whole square. So x plus 1 the whole square. Now further this of the form a square minus b square, which can be written as a plus b into a minus b. This is of the form a square minus b square, which can be factorized as a plus b into a minus b. This is of 8th standard. So a plus b, see here. This is of the form a the whole square minus x plus 1 the whole square. So a square minus b square, which is a plus b. This is your a plus b plus this is the b term. Take off the squares. You can make out the a and b terms. See here. This is a square, right? Look at the board. This one you're reading it as a square. So take away the square. So this is your a term. Now this is b square. Take away the square. This is the b term. So a plus b, a plus x plus 1 into a minus b, a minus x plus 1. Now open the brackets. A plus x plus 1, a minus x minus 1. So, and you have this answer in option C. Take it down. Sorry.
G and A times B as well as A square plus QAB plus B square.
Correct. Correct. Two identities in this factorization. Correct. Finished? You want to say something? Okay. Done, all of you?
Yes, miss.
Very good.
Yes, ma'am.
Yeah.
Yes.
Yes, ma'am.
Yeah, sure. Finished, right? All of you? Okay. On to the fifth one. Okay, in the fourth one, see, the question is the factors of this expression. So if you're asked to write the factors of 27, what are the factors of 27? Or 27 can be so factors of meaning, how can you factorize 27? It's 3 into 3 into 3. How do you factorize 15? 3 into 5. You must write the number as a product of its prime factors. You must write the number as a product of its prime factors. All right. So 27, you should not say 9 into 3 because 9 is not a prime number. Okay. So 27 is 3 into 3 into 3. So this is how you factorize 27. 15 is 3 into 5. In the same way, how do you factorize this expression? It is this expression into this expression. We're trying to understand the meaning of the question. The factors of this expression are this and this. Like 15 is equal to 3 into 5. So the factors of 15 are 3 and 5. Or 15 can be expressed as 3 into 5. All right. Okay. Question number 5. The degree of root 5 is, what's the degree?
1/2.
What's the degree of root 5?
1/2.
Now is root 5 a monomial, binomial, trinomial, constant polynomial, or a zero polynomial? Give a specific name. It's a constant polynomial. It's a constant polynomial. Root 5 is a constant polynomial. And what's the degree of a constant polynomial? 0. 0. See, root 5 is definitely 5 to the power 1/2. But Who defines the degree? The power of the variable. Nothing of the constant. Nothing of the constant. The power of the variable involved defines the degree. So root 5 is a constant. Where's the variable? So let's attach a variable x and raise it to the power 0. So what is x to the power 0? 1. And what is 1 into root 5? Root 5. So root 5 can also be written as, because to find the degree, you need the presence of a variable. The power of the variable helps you find the degree of that polynomial, right? So now this root 5 is a constant polynomial. Now root 5 can be written as root 5, any variable, say y to the power 0. Why? Because y to the power 0 is 1. And 1 into root 5 is root 5. It's still root 5. So what's the power of y? 0. The variable y is 0. So the degree of a constant polynomial is 0. You need a variable to find the degree of a polynomial. In root 5, you don't see the variable. So you introduce a variable. But you should not simply introduce a variable like this, because you're changing the value of root 5. Root 5 and root 5y, they are different. They're not the same. But if you write root 5 as but you can write root 5 as root 5 to the power, but you can write root 5 as root 5 y to the power 0. Because y to the power 0 is 1 and 1 into root 5 is still root 5. Now let's find the degree. Variable is y, power is 0. So the degree is 0. The degree of minus 100 is same thing, same understanding, 0, because it's a constant polynomial. The degree of a constant polynomial is 0. Then the degree of 0, not defined. It's not defined because 0 can be written in many ways. You can't give one answer. 0, you can write it as 0x to the power 0, 0x squared, 0x to the power 100, 0x to the power 55, because x to the power 55 into 0 is 0. X to the power 100 into 0 is 0. X squared into 0 is 0. So you write anything, 0 with anything, the result is 0 only. So you can write 0 in many ways. So if you write it like this, you will say the degree is 2. If you write it like this, you will say the degree is 100. If you write it like this, you will say the degree is 55. How can you give different answers for this question? It should be one answer. What is the degree should be one answer. So we say the degree of 0 is not defined. It's not defined. The degree of 0 is not defined. Because 0 can be written in different ways. So all of us can give different degrees for 0, which means the degree of 0 is not defined. Then the degree of this expression is online children. Okay. Yeah, okay. Yeah, okay. Online children.
Ma'am.
Yeah.
Ma'am.
Yes, ma'am.
Yeah. What's the degree of this polynomial?
1.
1.
1.
1.
Correct. It's 1. The degree is 1. Now, this is the polynomial. This is a polynomial of how many terms? 1, 2, 3, 4, 5, 6 terms. This is a polynomial of 6 terms. This is a polynomial of 6 terms. Now, this is the first term. The variable is a. Its power is 1. This is the second term. The variable is b. Its power is 1. Don't add the powers because the variables are different terms here. In one term, if you have many variables, you should add the powers. C is another term. Its power is 1. D is the next term. power 1. E power 1. This is a constant, so just ignore it. Now you're not supposed to add these powers because they're the powers of the variables in different terms. So the highest power is 1. It's 1 everywhere, so the highest power is 1, so the degree is 1. If it was A, B, C, D, E minus 7, then we have to add the powers. If this expression were like this, A, B, C, D, E minus 7, then A, B, C, D, E is one term. This one term has 5 variables. So 5 variables, 5 powers. So add the powers. A, B, C, D, E here is one term, a single term. Because you don't have the separator plus minus. So this one term has 5 variables. And the 5 variables have 5 different powers, or here the same powers. So here you'll have to add the powers. 1 plus 1 plus 1 plus 1 plus 1, 5. So the degree of this polynomial will be 5. A, B, C, D, E minus 7. The degree is 5. Yeah, do the 6th one. Yeah, finish the 5th one, 1 minute. Yeah. Finish this one. Done writing this, all of you?
Done, ma'am.
Yes, miss.
Yeah. All right. Next one. Next is the 6th one. Please write the question and then simplify the expression. And then give your answer. If the statement is true or false. Excuse me. Just simplify. Take down this expression, simplify the expression. That's what I told you. Simplified. You've taken the question, right? You simplified. Basic. True or false? False. Online children, is the sixth statement true or false?
False, ma'am.
True, ma'am.
Okay. The battle between true and false. It's true. Hmm. Okay. It's false. Okay. So it's 5y raised to the power 7 by 2 minus 11y raised to the power 3 by 2 minus y raised to the power 1 by 2 divided by square root of y. Now, what if you had a plus b minus c by d? How can you write this? I'll just start for you. I'll write it a by d plus, continue, b by d minus c by d, correct? A plus b minus c by d can be written as a by d plus b by d minus c by d. In the same way here, this is division by a monomial. So this one is 5y to the power 7 by 2 divided by root y minus 11y to the power 3 by 2 divided by root y minus y to the power 1 by 2 divided by root y. Correct? So this is nothing but 5y to the power 7 by 2 divided by y to the power half minus 11y to the power 3 by 2 y to the power half minus y to the power half by y to the power half. All right. Now, by the law of exponents, subtract the powers. So y 5 y to the power 7 by 2 minus 1 by 2 minus 11 y to the power 3 by 2 minus 1 by 2 minus y to the power 1 by 2 minus 1 by 2. So 5y to the power 7 minus 1, 6 by 2. And what 6 by 2? 3. 7 minus 1, 6 by 2. So 3. Correct? Shall I write 3 straight away? Minus 11y to the power 3 minus 1, 2. 2 by 2, 1. So y minus half minus half is 0. And y to the power 0 is 1. Yeah, now what is the statement? The given expression is a cubic polynomial. Is it a cubic polynomial? Why is it a cubic polynomial? Is it a polynomial? Yes, because the power of the variable y everywhere is a whole number. So it is a polynomial. Is it cubic? Yes, the highest power is 3. So it's cubic. So it is a cubic polynomial. The statement is true. Yeah, write down.
Finished, ma'am.
Yeah, very good.
Completed, ma'am.
Yeah. Next one. Seventh one. So 6, the statement is true. Sixth one, the statement is true. It is a cubic polynomial. Are you all recording everything correctly? Question. If we are simplifying, showing some working with the options, you must show that whatever I'm doing here, and then give your correct answer. Okay, the seventh one. The number of terms of the polynomial is 3. Number of terms 3. Which of the following are non-negative integer? I'll give you time to write. We'll just finish this. Which of the following are non-negative integers? Is this
13,
okay?
miss.
We'll do it one by one. Is 4 by 5 an integer?
No, ma'am.
No. Then why should we check if it's a non-negative integer? It's not an integer at all. Is minus 5 an integer?
Yes, ma'am. But it's negative.
Yeah. Minus 5 is an integer, but it is a negative integer. Oh. Is 0 an integer?
Yes, ma'am.
Is it non-negative? Yes, it is not. It's not negative.
Yes.
It's neither negative nor positive. So it's not negative. So yes. What about 13? Is it an integer?
Yes, ma'am.
Yes. Is it negative? No.
No.
So it's
No.
non-negative.
Non-negative.
Yeah. So the correct options are C and D. 0 and 13. 4 by 5 is not an integer at all. So leave it. Minus 5 is an integer, but it is a negative integer. You have to select non-negative integers. Then then only one correct option will be given to you. Here there are 2 correct options. Then how can you select one? Oh, so you're saying which is the best option? Huh? Yeah. No. Both are correct. Yeah. That can happen only with theory kind of questions. You'll have to select the most appropriate answer. So like, I'll give you a question like that. Okay. Here you cannot. So the correct options are 0 and 13. Both are integers and both are not negative. So they are the correct options. Both are non-negative integers. Yeah, 9. Binomial Okay, is the okay, is this one a polynomial? Okay. Is it a polynomial? See, to say it's a binomial, it has to be a polynomial first. Is the expression a polynomial? The power of P is 2 whole number. The power of
Yes,
Q is
ma'am.
1 whole number. The power of R is also 1 whole number. Everywhere, the powers of the variables involved are whole numbers. So it's a polynomial. It's an algebraic expression and it's also a polynomial. Because everywhere the variables have whole numbers as their powers. So this expression is a polynomial. And now how many terms it has? 1, 2. So it's a binomial. So binomial, correct. This expression, this polynomial is a binomial. Because it's a polynomial, you can say it's a binomial. It has 2 terms. But if it was only an algebraic expression and not a polynomial, then you cannot say it's a binomial. Then you can only say it's an algebraic expression with 2 terms. Since it's a polynomial with 2 terms, you can say it's a binomial. Then is it a polynomial of degree 4? Yeah, because this first term has how many variables in it? This first term has 3 variables in it. So find the sum of the powers of the variables. What's the power of P? 2, Q 1, R 1. So the power is 4 and the highest power is 4. Sixteen does not have a variable attached to it. So ignore this. P, Q, R, they're all in the first term. So we should add the powers. They're all variables in one term. So we should add the powers. 2 plus 1, 3, 3 plus 1, 4. So this is correct. It's a polynomial of degree 4 is correct. Then C, is it an algebraic expression? Yes. It's an algebraic expression. D, all of ABC. Yeah, we said it's a binomial. We said it's a polynomial of degree 4. And we also said it's an algebraic expression. So all of ABC is also correct. Go ahead. Only A. No. Only B. No. So this is the correct option. All of ABC. So this exercise is to give you a clear, deeper understanding of the basics regarding understanding the difference between algebraic expressions and polynomials, number of terms, and where you can say binomial, trinomial. Only if it is a polynomial, you can say binomial, trinomial. If it's not a polynomial, then you cannot use those terms. You can only say they are algebraic expressions with 2 terms, 3 terms, and so on. Okay, for the 9th one, the correct option is D, all of ABC. Then every algebraic expression is a polynomial. True or false?
False, ma'am.
False or true? False. Every algebraic expression is a polynomial. True or false?
False.
Every polynomial is an algebraic expression.
That is
Every
true.
polynomial, yeah. Every polynomial is an algebraic expression. True. Every algebraic expression is a polynomial. False. Every algebraic expression is a polynomial. False. If the algebraic expression has to be a polynomial, we'll have to check the powers of the variables. They all have to be whole numbers. Only then the algebraic expression is a polynomial. Yeah, complete this. Oh, I thought you both are this. Finish writing? Anika, done?
And ma'am.
Okay. All right. Yeah. Give one example of each of the following. You can continue the serial number. You don't have to start with one again. You continue the serial number. So give one example of each of the following. A polynomial of degree 1. 4x plus 4x plus 1. Okay. Yeah, you can share 10x. 10x plus 7. Now, is this a polynomial of degree 1?
No, ma'am.
Why no? Yes, it is. The power is 1. The power is 1. So the highest power is 1. So the degree is 1. And this is a polynomial of degree 1. Monomial of degree 0. 715. Monomial of degree 0.
5, miss. 5.
5. Just 5. So for degree 0, you can give any real number other than 0, any real value, any real number, 5 point, yeah, 5.15. 0 power is 0. Degree should be 0. For the second one, you can give any real number, any non-zero real number, any non-zero real number, any constant other than 0. Because the degree of a constant is 0. The degree of a constant is 0. So any constant example you can give, but not 0. Because 0 is a 0 polynomial and its degree is not 0. The degree of 0 is not 0. The degree of 0 is not defined. You have to write a monomial of degree 0. Degree 0 means you can give any constant term, but not 0. So any real number, not 0. All right. Then a trinomial of degree 20. That's only a binomial. 110 plus 300 is 410. When you even after simplifying, it should be a trinomial. See, like we feel a plus 4, okay, something like a to the power 20 plus 4 plus 5. This can be simplified, right? So that simplifies to a to the power 20 plus 9. So after you simplify, it becomes a binomial. So your example is incorrect. Even after simplifying, it should be a trinomial. Plus 18. Correct. Correct. Yeah, right on. Finish writing, Rahul. Done writing? Okay. So my example.
Just a second, ma'am.
What? Come again? 10x power 10. Okay. Okay. A plus B. Okay. So the first term has 10 and 10. So 10 plus 10, 20. Okay, correct. So you can write, supposing your teacher wants you to write in only one variable, then you can write x to the power 20 plus x to the power 10 plus x, like this also. If your teacher wants you to give an example on only one variable, then see here, x to the power 20 plus you can write 5x to the power 10 minus whatever plus 3x. Trinomial. Yeah, this one is also a trinomial of degree 20. Because here the power is 20, here the power is 10, here the power is 1, the highest power is 20. So the degree is 20. So you must take care of the conditions given. If they want you to give an example only, if they want you to give an example in only one variable, then you can write something like this. Only one variable x. Trinomial of degree 20 in only one variable x.
Finished, miss.
Yeah, good. Nice. Yeah. Complete all the four, then we'll see the answer. Finish it and then we'll discuss the answers. Try it yourself. Finished. Are you writing the statements or just the answer? You're used to that in your Okay. Yeah, online children, please participate. The polynomial has dash terms. How many terms? Three terms. Three terms. So it is a trinomial. It is a
Trinomial.
trinomial. Correct. The degree of the polynomial is
7.
7.
7, miss.
7, ma'am. 8, ma'am.
8. The degree of the polynomial is 8. See the first term. In the first term, how many variables? 2 variables, A and B. The power of A is 1. The power of B is 7. So 1 plus 7, 8 is the number for the first term. 8 is the number for the first term. The power for the first term is 8. Why? Because in the first term, we have 2 variables, A and B. The power of A is 1, B is 7. So 1 plus 7, 8. Second term, how many variables? Only one variable. What's its power? 1. Okay, so first one, it is 8. Now it is 1. Third term, variable is E. Power 7. Power is 7. So what are the numbers you have? 8, 1 and 7. Which is the greatest of these three numbers? 8. So the degree is 8. The degree of the polynomial is 8, not 7. Few of us went wrong, online students. If you have a question, any doubt, please ask me now. Clear?
Yes, ma'am.
All right.
Okay, ma'am.
The next
yeah.
one. The
Yes, ma'am.
numerical coefficient. Okay, good. The numerical coefficient of D is
Minus 1 by 5.
correct.
Minus
The
1 by
numerical correct. The numerical coefficient of D is minus 1 by 5. The numerical coefficient, number coefficient of D is minus 1 by 5. Correct. The literal coefficient of A, literal meaning letter. Literal meaning of letter. A, B, C, D, letters.
7.
So the literal coefficient of A is
D power 7.
B to the power 7, correct. B to the power 7. Here it is. Yeah, it is. You can see the question also, no? Because it's a statement. Or you want to see only the. Okay. Finished?
Yes, miss.
Yeah. Literal coefficient meaning only the letter. So here, the literal coefficient of A. What is the coefficient of A? What is the coefficient of A? 3A to the power 7. The coefficient of A, take away A. Whatever remains is the coefficient. Okay, see, in this term we have A. The coefficient of A. To answer that question, just take away A. This is the coefficient of A, 3B to the power 7. Now we can have more specific questions. What is the numerical coefficient of A? 3. What's the literal coefficient of A? B to the power 7. Coefficient of A is 3B to the power 7. If it is simply coefficient, write everything. Other than in that term, other than A, the rest of it is the coefficient of A. This term has A, right? If you want to write the coefficient of A, take away A from that term. What do you see? 3B to the power 7. That is the coefficient of A. Other than A, the rest of it in that term is the coefficient of A, 3B to the power 7. Now, more specific question. What is the numerical coefficient of A? So take away A, this is the coefficient, but the numerical coefficient is 3. Not 7, don't write the power 7. 3, this one. Now, what is the literal coefficient of A? This is A, take it away. So this is the coefficient. The literal coefficient, that means don't write the numerical coefficient. Don't write this. Write only the literal coefficient, which is made up of letters. So B to the power 7. So 3 questions. Coefficient, numerical coefficient, literal coefficient. Numerical coefficient, write only the number. Literal coefficient, the letter. Coefficient, write everything other than, like in this case, like if it is coefficient of A, other than A, write everything else in that term. Clear? Finish writing, online students?
Yes, ma'am.
Okay. Okay, 3 you can write for yourself, or I'll just show you the slide you can write down. Do the fourth one. We'll do the fourth one now and then do the third one. Answer this one. We'll do it. After the fourth one, we'll do. Yeah. Oh. Finished? Correct. Finished? Yeah. All right. Yeah. So we'll do the fourth one, as I told you, and then do the third one. So we're given this polynomial. Answer these questions related to, or complete these statements, not questions, complete these statements with respect to this polynomial. Who's this? Correct. Yeah, no. Somebody's parent is waiting there. Can just go out and ask him to come in and sit down. Yep. Yeah, the polynomial has one term. The polynomial has one term. So it is a monomial. It's a
Monomial.
monomial. Very good. The polynomial has one term. So it is a monomial. Next, the degree of the polynomial is
4.
the degree is what, children? 1 or 4?
4.
4. Because this is one term, and in this one term there are 4 variables. So we'll have to find the sum of the powers. 1 plus 1 plus 1 plus 1, 4. Add the powers of the Sanjay. So 4. Biquadratic, not bio. You like biology, is it? Yeah, so bioquadratic. No, this biquadratic. Okay. Yeah, the degree of the polynomial is 4. So it is a biquadratic polynomial. The numerical coefficient of C is
Root 5 by 8.
yeah, numerical coefficient of C. So this is C. Take away C. But these are letters, so you should not write them. Write only the number. So it is root 5 by 8. The literal coefficient of C is yeah, this is C. Take away C and take away this also because it is a number. The rest of it, A, B, D. A, B, D. Yeah, you can see the answers here. Please complete. Can you just help me, Smriti? Just turn on the light, no? The bottom row. Bottom row, ரெண்டு switch இருக்கும்ல அது போடுங்க. Bottom row. இன்னொரு switch போடுங்க. I think வெளில fan இருக்கு. Done? Okay. Yeah, complete this one. This is the third one. Please complete this. You can give different examples also. This is the third one. Write down. No, we'll do our work. I'll take care. Yeah. Finish the fourth one, Rahul. Okay, this is the third one. If you've already finished it, you'll have to wait. Yeah. I'll take care, no? I'll take care, you don't worry. No, I want you all to do your work. I'll take care. You finish your work. Done?
Yes, miss.
Very good. Sorry? Homework. No, homework I haven't still planned. I'll send it later. No. I didn't get your question. We discussed. Oh, we have to discuss the answers to the homework questions, is that? No. Yeah, you will.
Completed, ma'am.
Yeah, done?
Yes, ma'am.
No, see, don't get distracted. Yeah. This is your next question. Okay, so what's the degree of the polynomial? Okay. One more time. Yeah, all right. I'll wait. Yeah. Okay. So what's the degree of the polynomial? Online students, please participate. Degree of the
11.
degree of the polynomial.
It's 11,
miss.
ma'am.
6.
11.
6. 6, correct.
6, ma'am.
Degree of the polynomial is 6, correct. The coefficient of x cubed,
1/5.
1/5. The coefficient of x cubed, 1/5. Correct? The coefficient of x to the power 6 minus 1. The constant term, 3/5. No. 5 minutes more. 5 more minutes. Yeah. So this is the polynomial, right? The polynomial is x cubed by 5 plus 2x by 5 plus 3 by 5. It's x cubed by 5 plus 2x by 5 plus 3 by 5 minus 7 by 2x square minus x to the power 6. Now I have written the terms in the descending order of the powers of x. I've rearranged the terms in the descending order of the powers of x. It's just a presentation, criteria. That's it. No, nothing like that. It's just a presentation criteria, nothing else. So minus x to the power 6 first, power 6, then power 3, then power 2, then power 1, then the constant. Have I written them correctly? Minus x power 6 plus x cubed by 5 minus 7x squared by 2 plus 2x by 5 plus 3 by 5. Now answer these questions. The degree of the polynomial is 6, correct? The coefficient of x cubed 1 by 5 plus 1 by 5. No. The coefficient of x cubed, you should not write x cubed. Coefficient of x cubed, you should not write x cubed. Cover x cubed. Write the other remaining, remaining things you see in that term. So the coefficient of x cubed is 1 by 5. Then the coefficient of x to the power 6 minus 1. Correct? The degree is 6. This one is 1 by 5. Coefficient is minus 1, right? And the constant term is 3 by 5. 3 by 5. Right? All of you got that? Rahul?
Got it, ma'am.
Yeah, good. Yeah. We'll answer this and wind up the session for today. Determine the degree of each of the following polynomials. Just the degree, nothing else. Determine the degree of each of the following polynomials. Zero. That's what. Now, when I say yes, no, correct. No, I'm not saying anything. You're saying? Okay. No. You give me your answer. That's all. Your answer is 12 for the second one, right? Yeah. You think if you want, you can. Yeah, you can check. You can change your answer if you feel you were wrong. Right? Okay. So the first one, what's the degree? 5. 5. Because the highest power is 5. Second one, we need to simplify. So it'll be y cubed minus, should multiply, right? Y cubed into y to the power 4. What is y cubed into y to the power 4? When bases are same and it's multiplication, you need to add the powers. See, second one, y cubed into 1 minus y to the power 4. Y cubed into 1 is y cubed minus this into this. This into this. Y cubed into y to the power 4. So what do you do when bases are same and it's multiplication? You add the powers. So it'll be y cubed minus y to the power 3 plus 4, 7. So what's the degree? 7. When do you multiply the powers? If it is y cubed, the whole power 4. Then we multiply the powers. 3 4s are 12. Here it is y cubed into y to the power 4. So bases are same and its multiplication, add the powers. Y to the power 7. Yeah. So for the second one, what's the degree? 7. Third one, 1. And the fourth one is a constant. So its degree is 0. 0. Got it, all of you?
Yes, ma'am.
Okay. Online children, use the emoji, raise your hand. Gayatri, Shreya, Nuved, Lakshana, Haridarshan, Harsha, Yarni, and Danyashri, are you there? Are you there, Danyashri?
Yes, ma'am, but I cannot raise my hand right now, ma'am.
All right, no problem. Okay.
I think
All, yeah, okay. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Good
Thank you,
night.
ma'am.
Thank you, children. Good night. See you. You wait. Yeah. Class.